Today we're going to talk about section 2.7, which is on using absolute value functions and transformations. Our goal today is to be able to write and graph absolute value functions. So the first part of this section, we're going to be talking about the absolute value function. And then later on in the section, we'll talk about those transformations. So when we talk about this symbol right here, that means the absolute value of x. So x, if x is positive, it's 0 if x is 0, and it's negative x if x is negative. So when we get to it, just remember the absolute value of x is always going to equal a positive number. So when we put in a number and we take the absolute value of it, it will become positive. So the absolute value function is a function that contains an absolute value expression. So here we have f of x equals the absolute value of x, which is also the parent function. Now we can also write the parent function as y equals the absolute value of x. That's in xy notation. The other one is in function notation. So the graph of f of x equals x is a v-shaped graph, and it's symmetrical about the y-axis. So for every point xy in the graph, the point negative xy is also on the graph. Well, think about it this way. Put in 0, we get 0. Absolute value of 0 is 0. Put in 1, absolute value of 1 is 1. So put in 1, we get 1. Put in 2, absolute value of 2 is 2. Put in 3, we get 3. And so if we notice, we graph this side. The right side has a slope of 1. Now let's put in the left side. You put in negative 1. Well, the absolute value of negative 1 is 1. Absolute value of negative 2 is 2. Negative 3 is 3. And so we graph it this way. Now, the slope of the left side is negative 1. So it's going to bring us to another definition, which is called the vertex. And the vertex of an absolute value function is the highest or lowest point on the graph of a function. So basically, it's the turning point. It's the point where it changes from going down to up or up to down. So if the V opens up, the vertex is going to be at the bottom. If the V opens down, then the vertex would be at the top. So we're going to talk about different types of transformations, and a transformation changes the graph size, shape, position, or orientation. Now the one we're going to talk about the most today is a translation, and that's a transformation that shifts the graph horizontally or vertically, but does not change its size, shape, or orientation. So we're just going to take the whole graph and we're going to slide it one way or another, or up and down. So that's what a translation is going to be. The absolute value function is y equals x minus h plus k, where here the graph is translated h units horizontally, the graph is translated k units vertically, and the vertex of the graph is hk. So that's the big part here. The vertex is h comma k. So now notice here you have a negative sign inside there, so it's going to be kind of the opposite, whatever the h is, and then whatever k is. So let's go to example 1. Graph this function and then compare it with the parent function. So the first thing I'm going to do, I'm just going to throw my parent function on here quick. That way we can compare it with it. So if we want to graph y equals absolute value of x minus 1 plus 3, the first thing that I would do is I would always find the vertex. And we said the vertex is hk. So here's h, that's 1, and here's k, that's going to be 3. So the vertex is going to be 1, 3. So what you can do is just put in a couple points. So put in 2. 2 minus 1 is 1. Absolute value of 1 is 1. 1 plus 3 is 4. So we have 2, 4. If you put in 3, 3 minus 1 is 2. Absolute value of 2 is 2. 2 plus 3 is 5. Okay. Then if we put in negative 1, negative 1 minus 1 is negative 2. Absolute value of negative 2 is 2. 2 plus 3 is 5. And we skip 0, so let's put in 0. 0 minus 1 is negative 1. Absolute value of negative 1 is 1. 1 plus 3 is 4. And there we go. So now it says compare this. Well, it has the same shape, same size, same orientation. So we are going to say that we shifted this graph using a translation. So we're going to say we translated this graph up 3 units and right 1 unit. So up 3 units and right 1 unit. Next, we're going to talk about stretches, shrinks, and reflections. Now we want to make sure to pay attention to these because this is going to come back to us later when we're graphing quadratics and other types of things as well. So stretches, shrinks, or reflections. First of all, when A equals 1, when A equals 1, it's the same size, shape, and orientation. The graph of y equals A times the absolute value of x is a vertical stretch or a vertical shrink of the graph y equals absolute value of x. So what we're looking at in this case is we're going to take that is going to be our general equation for all absolute value functions. And we'll talk about that later. But if that a value is bigger than 1, it's going to be, that slope on the right side is going to be steeper, so it's going to be a vertical stretch. If that fraction is less than 1, it's going to be a vertical shrink. Now, they have absolute value on those because they need them to be positive. The negative just means it's going to be a reflection, okay, which is down below. So a transformation that flips it is going to be a reflection. And so if A is negative, then it's going to flip it. So in this case, again, I'm just going to throw the parent function up here quick so we can see how they compare. So if I make a table of values, I put in 0, I get 0. So same. If I put in 1, I'm going to get 1/3. Okay, if I put in 3, I'm going to get 1. If I put in -1, I get 1/3. And if I put in -3, I get 1. So the black one is our graph of this function. The blue is the parent function. So in this case, the black one is vertically shrunk by a factor of 1/3. So if we go over to B, again, I'm just going to draw the parent function. And after we get the habit of seeing this, you don't have to draw it on there all the time. But now, I'm going to make a table of values. So if I put in 0, I get -2. Oops, sorry. Nope, if I put in 0, I get 0. Absolute value of 0 is 0 times -2 is still 0. So there's that. If I put in 1, I get -2. If I put in 2, I get -4. If I put in -1, we're going to get -2. And if I put in -2, we're going to get -4. And so there's our graph. Now in this case, look, it's skinnier. So this is going to be different than the parent function, also because it opens down. So we're going to say that this is a reflection. I'm going to write it up here. A reflection and a vertical stretch by a factor of 2. So these are vertical shrinks and vertical stretches. Now if we look at example 3, this equation is the equation that I would put on your note card. You're going to want to use that. Y equals A times the absolute value of x minus h plus k. And again, you can go through and make table of values for all of these. But what I would recommend doing is using the vertex. Well, we know that the vertex is going to be -3, -2. Because by rule, this is really x minus, so then if we put that in there, it would be written like that. Because we have to make it look like this formula. So essentially, if you want to look at that, it's the opposite of whatever is that 3. So it's -3, -2. And then this number here is going to be the slope of the right side. So if I know that, I'm going to go up 1 over 1, 2, 3, 4. Up 1 over 1, 2, 3, 4 the other way. And there's your graph. Okay, and again, if we compare this with the parent function, we're going to say that it's a vertical stretch by a factor of 1/4 and a translation of 3 units left and 2 units down. So that's how we would graph those. And again, you can make a table of values if you want, but if we see the pattern that the vertex, we can plot that and then use the slope as the right side, and then obviously the other side would just be the opposite of that. So here are a couple practice problems in the guided practice. So go ahead and do questions 1, 2, and 3, and then you can hit pause and you can hit play when you are ready to move on. And here are the answers to your guided practice. Now I just graphed those. One thing we didn't do before, what we should probably do is put the vertex on each one of your graphs. If we look at number 1, it is a translation of 2 units to the right and up 5 units. Number 2 is a vertical shrink by a scale factor of 1/4. And number 3 is a reflection. It's a vertical stretch by a factor of 3. And it's a translation of 1 unit to the left and 2 units down. So now what we're going to do is we're going to jump to example 4. They're going to write an absolute value function. A landscaper sketches the design for a triangular shrub protector on graph paper. Write the equation of the shrub protector. Now, on your notes, you have that. I'm going to draw it up here real quick. All right, so what we're going to do, is we're going to start with a form. The general form of this. So y equals a times absolute value of x minus h plus k. So the vertex we know is 5, 6. So we're going to plug that in. X minus 5, absolute value of that plus 6. And now I just need to find the slope of the right side. Well, we can find the slope of the left side because we know that that was the point 0, 0, the origin, and the point 5, 6. So that means it goes up. The rise is 1, 2, 3, 4, 5, 6, and the run is 5. So that's 6/5. So this has a slope of 6/5. Well, the other side then obviously is going to have a slope of -6/5. So you can write that as either a fraction or you can write that as a decimal, but if we do it as a decimal, it's 1.2 and it's negative, so it's negative 1.2. And so here is the equation of that. Y equals 1.2 times the absolute value of x minus 5 plus 6. Now if we look down here, we're going to talk about the transformation of any graph. Okay, of y equals a times f of x minus h plus k can be obtained from the graph of any function, y equals f of x, by performing the same steps. Again, it's going to be a vertical stretch or shrink depending on the factor of a. If a is bigger than 1, it's a stretch. If a is a fraction smaller than 1, it's going to be a shrink. If a is negative, it's a reflection. And then also translating it from left to right, horizontally is h, up and down vertically is going to be k. So in example 5, what we're going to do is we're going to look at a graph. And again, you have this one on your notes, but I'm going to draw it here real quick. All right, so here's the graph that you have in your notes. What we're going to do in A is it says we're going to reflect this, and then we're going to change it to a scale factor of negative 1/3. So what we really need to do is find the endpoints, or any of the points that change direction. Okay, and you can multiply it by negative 1/3. So if we flip it, you can do this in a couple of different ways. First of all, we could just flip it, and then we didn't have to worry about the scale factor. So we could do that, or you can multiply each of those by negative 1/3. So let's start by doing it, just flipping it. So it's going to be, instead of negative 3, it's going to be negative 3, 3, 0, 0, and then 3, negative 6, it'll be 3, 6. Okay. And I'm just going to do a dotted line here because this isn't really my graph, but that's what it would be if I just reflected it. Now, I need to multiply the y value, because f of x is the y value, by 1/3. So instead of, this is a point 3, negative 3, 3. So now it's going to be 1. So I'm just multiplying the y value by 1/3. Well, this one obviously is 0, 0, so it's going to be 0. And this one is 3, 6, so that's going to be 3, 2. And so here, the blue one is the graph of that new function. So now we're going to do the same thing with the other one. And again, this tells us it's going to be a shift because it moves right 1 unit and up 3 units. So we're going to take this graph and we're going to move it right 1 and up 3. So right 1 and up 1, 2, 3. So let me just put these on here quick. Just easier to do it if they're here. So take these points, right 1, 1, 2, 3. Right 1, 1, 2, 3. Right 1, 1, 2, 3. And so here is the graph of that. So notice we do the same thing we do with the absolute value functions, only now it's a shift with a general function. So go ahead and take a couple minutes to do the guided practice questions, and they begin on page 126. So go ahead and pause the video. You can hit play when you're ready to move on. All right, so if we look at the answers to the guided practice for question 4, it says the beam originates at the ordered pair 3, 0 and goes to the reflected at 0.54. So therefore 5, 4 would be our vertex. So that goes in for H and K. And then if we look from 3, 0 to 5, 4, that side has a slope of 2, which would give the whole graph a slope of -2 because it opens down. So your equation is y equals -2 times the absolute value of x minus 5 plus 4. Now in questions 5, 6, and 7, the black line is the original graph. So in the first one, all we had to do is take and multiply the y values by 1/2. And so there's our new ordered pairs. In number 6, we had to do two things. Now, I like to do them one step at a time. So if you see, I reflected it, so that's negative. So I flipped it upside down, and that's the blue dotted line. And then from there, I took and did the translation. So I went 2 to the right and down 5. And so our answer is this shape down on the bottom with 2, -5, 4, -8, and 7, -8 as those ordered pairs. Then in number 7, again, I had to do 2 things. I did a vertical stretch and a translation. So I did a vertical stretch first, which again is that blue dotted line, and then I shifted everything to the left 3 units and down 1 unit. So that gives us, and I didn't write the ordered pairs here, but it's -3, -1, -1, 5, and 2, 5 as the ordered pairs for our new function. So if we take a look back at section 2.7, it is on absolute value functions and transformations. Okay, so we looked at how to transform different types of functions, and specifically absolute values. So remember, if A is negative, that means it's going to be a reflection. If it is a number bigger than 1, it's going to be a vertical stretch. If it's a fraction smaller than 1, it's going to be a vertical shrink. And then it's going to be a translation of H units to the right or left and K units up or down. So here is your assignment from section 2.7.